Hi, in this video, I'm going to solve a numerical from chemistry from a recent IIT JEE paper. So let me read the question out to you first. I have 1 gram of a carbonate M2CO3, which on treatment with excess HCl produces some amount 0.01186 mole of carbon dioxide gas. And the question asked here is, what is the molar mass of M2CO3? That's what we need to find out. And we have 4 options that are given to us. So let's go ahead and solve this. Yeah. So what's given here first? I have that M2CO3 reacts with HCl, which is excess. I'm just going to write that here, and this gives me CO2. And precise amounts are given, right? I have 1 gram of this, and I have this much of this guy formed. Yeah, that's what's given to us. So how do we go and solve this? So clearly it looks like this is a stoichiometry numerical, right? From what it looks like, I have some ratios and proportions, and I need to find out the molar mass of M2CO3, right? Now, what is molar mass exactly? You guys already know this, right? It's the mass that is possessed by 1 mole of any substance, right? So this is something that is known to us already. So how can we use this information to solve this question? Let's do this. So using simple ideas from inorganic chemistry, I know that this looks like this is a metal carbonate. On reacting with HCl, it gives me CO2, that is given. I also know that this is going to form some more things. Yeah, let me write them down. It's going to form some water, and it's also going to form a chloride, MCl. Are you with me on this? Let's see why I wrote MCl. This is kind of important here. I wrote MCl and not MCl3 or M2Cl or something like that because you know that CO3 minus, this has a 2 minus charge, right? And since the compound that we have here is M2CO3, this means that the metal M has a valency of +1, which means it will form this compound MCl. Yeah? That was the reason why I did this. Now, why am I doing this? Remember, this is stoichiometry numerical. I need to balance this reaction. Only then can I figure out what to do next. So let's do that first. Yeah. On balancing this reaction, I just have to put a 2 over here and another 2 over here at MCl, and that's it. This reaction is balanced. Take a look to see if you're convinced or not about this. Now that we've balanced this, what do I do next? The rest is pretty straightforward. I need to find out the ratio of these guys. Yeah, what is the ratio of M2CO3 is to CO2? Basically, how much M2CO3 gets consumed in producing carbon dioxide? You know that's clearly simply 1:1, right? I'm talking about mole ratio. Yeah, remember all these calculations have to be in moles. So again, why is this important? I know that 1 gram of M2CO3 produces 0.01186 moles of CO2. This also is the same amount of M2CO3 that is consumed, right? So now we have a direct relationship of M2CO3, which is my area of interest. So I know that 1 gram produces, it's consumed 1.00186 moles of M2CO3. Now what's left to do? I need to find out what is the weight that would have 1 mole of M2CO3. This is simple cross multiplication, also known as a unitary method. So the molar mass, remember, let's just go up here. Yeah. So molar mass is simply the mass contained in 1 mole of the substance. So I can say here very easily now that molar mass is simply going to be equal to 1 into 1 divided by 0.01186 gram per mole. This is a simple calculation, although it looks a little complicated. Now, when you come here, you know right away that option 2, 3, and 4 get eliminated, and the answer is obviously answer, this right here, which is option 1, 84.3. If you do this calculation, you'll actually get that value. Now, let me just walk you through or summarize what we did here, yeah, from the methodology to what we actually applied. So we saw that, okay, this was a question. We figured that this is the reaction that goes on there. You need some inorganic chemistry ideas to complete this reaction because you need to balance it. Only if you balance it, then you know the ratio, the molar ratio of M2CO3 to CO2. Once you have that, then you use simple unitary method to figure out what the molar mass was. I hope this was clear. See you around.